Squares and square roots. In this video, we'll learn how to find square roots using repeated subtraction method, prime factorization method, and division method. Square roots. The square root of a number m is that number which when multiplied by itself gives m as the product. Say n be any natural number, then n into n is equal to m, or n square is equal to m, then we say n is the square root of m. Square root of a number can be represented using this symbol square root m. So when we say n into n equal to m or n square equal to m, root m will be equal to n. Now by looking at any number, we can easily identify whether it's a perfect square or not. We can definitely tell that a particular number is not a perfect square by looking at its units place. When the units place has got 2, 3, 7 or 8, it is definitely not a perfect square. But when it has got 0, 1, 4, 5, 6 or 9, it doesn't mean that it is a perfect square. This number is not a perfect square as it has got 2 in the units place. So 2, 3, 7, 8 in units place means it is not a perfect square. Also, when we have zeros at the end of a number, just count the number of zeros there. If the count is odd, then it is not a perfect square. Here we have 3 zeros, which means this particular number is not a perfect square. Now we'll see how to find square roots using different methods. Repeated subtraction method. In this method, from a given number, we have to start subtracting the odd numbers. Odd numbers we have to consider from 1, and from there the successive numbers have to be subtracted from the given number. After doing subtraction, we may reach a point where we get 0 as a result or a number that is less than the next number to be subtracted. If we reach 0, then we have to count the number of times we have done subtraction, and that particular number gives the square root of the given number. Now let us understand this with help of an example. Consider 81. First step is to subtract odd numbers from it successively starting with 1. So first thing is 81 minus 1, that gives 80. Now take this 80, from this we have to subtract next odd number, that is 3. This gives 77. From this 77 we have to subtract the next odd number, that is 5. In this way we have to successively subtract the odd numbers. After doing it for some time, we will reach a point. Here it is 0. If we reach this 0, the last step 17 minus 17 equal to 0, which means the given number is a perfect square. But how to find the square root of this number? For that, count the number of times we have done the subtraction. So here if we count 1, 2, 3, 4, 5, 6, 7, 8, 9. In total we have done subtraction 9 times, as the count is 9 here. So from this we can tell that root 81 is equal to 9. Let us take another example. Now let it be 45. We will again start subtracting from 1. So first step is to do 45 minus 1, that is 44. Like that we will continue. Here if we see, the last step is 20 minus 11 equal to 9. And the next odd number we are supposed to consider is after 11, it is 13. The number we have got here is less than the next odd number, so we have to stop here. As we didn't reach 0 by doing subtraction of odd numbers, the given number is not a perfect square. Coming to the next method, it is prime factorization method. In this method, the given number has to be written as a product of prime numbers. And these prime factors, then we have to pair them in such a way that each pair should have both factors same. Once we are able to pair all the factors of a given number, then consider only one number from each pair and take product of those numbers. That particular product is the square root of the given number. We'll look into an example. Consider 324. Now this 324, we have to start finding the prime factors. For that, we'll start dividing this number. 324 is a even number, so we can start with 2. On dividing with 2, we'll get 162. 162 is also even, so again with 2, this gives 81. Now 81 is not even, so we'll check in third table. In third table, it goes 27 times. Now again, this is odd, so third table again 9 times. Again, third table 3. Here we can stop this as the last 3 is a prime number. Now this 324 can be written as product of these numbers, whatever we got in the division. On writing this, it will look like this. This gives the prime factorization of 324. Now, from this prime factorization, we'll start pairing the factors in such a way that each pair should have both factors same. So, initially it is 2 into 2, we can pair those. The step is to pair the factors. 2 into 2 is one pair, then 3 into 3 is one pair, both factors are same. And again, we have 3 into 3, it also forms a pair as both are same. Now, once this pairing is done, we have to pick one number from each pair. So, from the first pair, we have to pick 2, and in the second pair, we have 3, and the last pair is again 3. Once we are done with picking, we have to multiply these numbers to get the product. Now, 2 into 3 into 3 is 18. This 18 is nothing but the square root of 324. You can write root 324 equal to 18. I will take another number 252 here. Again, this also we have to convert into prime factorization. As it's even, we'll divide it with 2. Now, after division, 126 is also even. So, again, we'll consider second table. This gives 63. As 63 is odd, we'll go for third table, 21. Again, this is odd number, third table, 7. Now, after reaching 7, as it's a prime number, we have stopped here and we have written 252 as a product of these numbers. Now, if we observe these numbers, as a part of next step, we have to pair the factors. So, on pairing the factors 2 into 2, they form one pair. Then 3 into 3 forms another pair. 7 is alone. We don't have another 7 to make it as a pair. This means the given number 252 is not a square number. It's not a perfect square. This prime factorization is useful to answer questions like this. So the question might be like, find the smallest whole number by which 252 should be multiplied so as to get a perfect square number. Now we know that 252 can be written like this: 2 into 2 into 3 into 3 into 7. And we also have done this grouping. If we get another 7 here, means into 7, then it forms a pair. To multiply 7 on the right hand side, even on the left hand side also, we have to multiply the number with 7, so the balance of the equation doesn't get disturbed. Now, multiplying with 7 on both sides, the number gets converted like this. As we have only pairs on the right hand side, it means the left hand side number is a perfect square. From this, we can answer the question like, the given number should be multiplied by 7 to make it as a perfect square. On multiplication, we'll get 1764, and the square root of 1764 here is 2 into 3 into 7, that is 42. Let us check with another number. Now we have 396 and we need to find the smallest number by which this particular number has to be divided to make it as a perfect square. Now on doing prime factorization of 396, we'll get the prime factors as 2 into 2 into 3 into 3 into 11. Now when we pair these, we'll have 2 into 2 paired as one group, 3 into 3 is the second one, and the 11 is left alone. How to remove this 11 is just to divide this particular prime factors with 11. So on both sides, if we divide with 11, it gets converted. Now the 11 will get removed, and that makes the number a perfect square. So 396 has to be divided with 11 to make it as a perfect square. When we divide 396 with 11, it gives 36 as answer. So 36 is equal to 2 into 2 into 3 into 3. So for square root of 36 would be 2 into 3, that is 6. Next is division method. In division method, we will understand this method with the help of an example. Let us consider 529 as a given number. Now when we have a number like this, the first step is to place bar over every pair of digits starting from the units place. If the number of digits is odd, then place a bar on the extreme left single digit. Now consider this number starting from units place 9 and 2, those two form a pair. So we'll have a bar over that. Now 5 is left alone, it is a single digit. Even on that, we will keep a bar. Now it will look like this. So on 2 and 9, one bar, over 5, another bar. Once we are done with placing bars like this, the second step is to find the largest number whose square is less than or equal to the number under the extreme left bar. And that particular number should be written as both divisor and quotient. Now take the number we have. The first step is to start the division process. This division process will be a little bit different from the usual division process. Now what we are going to do in this division is consider the digits under extreme left bar. Here we have only one digit, that is 5. Now this 5 is not a perfect square. So we have to take a perfect square that is just less than the 5. 4 we have, and 4 is a perfect square. 4 is less than 5, so we can consider that. And 4 is nothing but 2 square. So now this 2 is the required largest number, and its square is less than the number under the extreme left bar. So this 2 has to be written as both divisor and quotient. We'll write in both the places divisor and quotient like this. Now 2 into 2 is 4. We'll write it down and then do the subtraction. This gives 1 as the remainder. In the next step, we have to bring down both the digits under the next bar. So now here we have 2 and 9 under the next bar. Both the digits we have to bring them down. This will form the new dividend. Once we have new dividend in place, double the quotient that is already there and write that quotient with a blank beside it as a new divisor. Now we have 2 as a quotient. Doubling means just multiply that quotient with 2. 2 into 2 is 4, and then after 4 we have to write a blank, and that will be written as the divisor here. On finding the new divisor, now we have to think of a digit in this blank place in such a way that after placing that new digit here, the divisor when multiplied by the same digit, it should give a number that is either equal to the dividend or just less than the dividend. Now here we have 129 as the dividend. 9 is there in the ones place, which means this can be given only on multiplying 3 with 3 or 7 with 7. Only in those cases will have 9 in units place. So we'll try to place 3 here in this blank, that is in blank when we place 3, 43 into multiply with the same number into 3. This gives 129. So that's the required dividend value. So we'll place the value here in divisor and the quotient as well. Write 129, perform the subtraction 0. Now as we have got remainder as 0 here, this shows that the given number is a perfect square. From this we can write root 529 equal to 23. That is the quotient we have after division. We'll try to understand this method with the help of another example. 5607. Now the first step is to place bars over the number. On placing the bars, the number will look like this. Consider this number and start dividing. Under the extreme left, we have 5, 6. Those two are the 56 is not a perfect square, so we have to think of a square number that is just less than 56. We know that 49 is a perfect square and it is less than 56. And this 49 is nothing but 7 square. So 7 is the required number that should be written as divisor and quotient. We place 7 in both the places of divisor and quotient. Now write 49 and perform the subtraction. This gives 7 as the remainder. In the next step, we have to bring down both the numbers from the next bar. So 707 is the new dividend. Now we have to double the quotient and write with a blank beside it as a new divisor. 2 into 7 is 14. So 14, after 14 we have a blank. In the next step, we have to identify a number in this blank such a way that when we multiply this new divisor with the same digit, it gives the value, the new dividend value, or a value that is less than the dividend. Now in 707, 7 is in units place. 7 can't be written as a product of any two similar numbers. So just below 7 we have 6, which can be obtained either by multiplying 4 into 4 or 6 into 6. We'll try both of them. So in place of this blank 14, after that we have a blank. We'll try to keep 4 first and multiply the number with 4. This gives 576. 576 is less than 707. So we'll try with the next number also. Place next number in the blank. Means in place of 4 after 14 we'll keep 5. That makes 145 into 5. The result is 725, which is more than the new dividend. So we'll use 4 itself here. Place 4 in the divisor and even in the quotient place and write the result here 576. On subtracting we'll get 131. Now again the new divisor has to be calculated by doubling the quotient. If we double the quotient, 74 into 2, that gives 148. After that, we should keep a blank. But this 148 is greater than the dividend 131. So we can't do this further. We have to stop it here, which shows as the remainder is not 0, the given number is not a perfect square. This division method is useful in answering this sort of questions like find the least number that must be subtracted from 5607 so as to get a perfect square. Now in the previous one, once we are done with doing the division process, 131 is the remainder we have got. So from the original number, if we subtract this value, that gives a value which would be a perfect square. So on subtracting 131, we'll get 5476. So this 5476 will have a square root 74, which is nothing but the quotient we have seen in the previous step. In this video, we have seen how to identify a given number to be a non-perfect square depending upon the value in its units place or depending upon number of zeros at the end of the number. And then the different methods to find square roots like prime factorization, repeated subtraction and division method. We have also seen how to convert a non-perfect square into a perfect square using prime factorization method and division method. In prime factorization method, we will either multiply or divide the given number to convert it as a perfect square. In division method, we have to subtract a particular value from the given number to make it as a perfect square.